In this lesson, we continue to practice adding, subtracting, and multiplying, doing operations with our new complex numbers. And remember, when we defined the imaginary unit, we defined I as the number whose square is -1. We defined the number I, the imaginary unit I, as the square whose square is -1. So I need to do x plus I squared minus x minus I squared. So to do x plus I squared, we get x squared plus I, x plus I. Sorry, x plus I times x plus I, which gives me, I got a step ahead of myself, x squared, ix, I squared. But whenever you see an I squared, we're going to make the substitution that I squared is really equal to -1. So from that first parenthesis there, I get x squared plus 2ix minus 1. Minus, now I'm going to square that out. And I'm going to get, let's see, make a table, x minus I, x squared minus ix positive I squared, but I squared is -1. So I get x squared minus 2ix minus 1. I have to distribute that -1 that's in front of that negative there, and get x squared plus 2ix minus I minus x squared plus 2ix plus 1. Those add to 0, those add to 0, so I'm left with this expression is equivalent to 4ix. Express 1 plus I squared in a plus bi form. Well, 1 plus I squared is taking the number 1 plus I times 1 plus I. 1 I squared. So this is really 1 plus I squared is really 1 plus 2I plus I squared. But wait a second, whenever I see an I squared, I can replace it with -1. 1 minus 1 is 0, so I'm left with 2I. So 1 plus I squared is 2I. Use your previous answer to find 1 plus I to the fourth. Well, that's 1 plus I to the fourth means I have 4 of those being written out. I have to multiply 4 of those together. But I already know if I multiply 2 of them together, I get 2I. If I multiply those two together, I get 2I. So 1 plus I to the fourth is really 2I times 2I, which happens to be 4I squared. But whenever I see an I squared, I know that's really -1, so 4 times -1 is -4. And wait a second, 1 plus I to the 8th is squaring that thing. 1 plus I to the 8th is 1 plus I to the 4th squared. So it's -4 squared, which happens to be 16. So that is the number there that we call 16. Find x minus I squared times x plus I squared in simplest form. So you could do this by squaring this, and multiplying those together. However, there's a slick way to do it. There's a slick way to do it. That's what it means to square x minus I. That's what it means to square x plus I. You can multiply those together, but if I multiply these together, if I do one of the negatives and one of the positives, life becomes much simpler. If I do x minus I times x times, I don't know what I'm doing here, x minus I times x plus I. So I'm multiplying one of these negatives with one of those positives. I get x squared minus ix, and negative I squared. X squared plus 0 minus I squared. I squared is -1. -1 is x squared plus 1. So this is really x squared plus 1 That's what happens when you multiply those two together. When you multiply those two together, you also get x squared plus 1. So I'd much rather make a table with those two. So there was a quick looking for on making use of structure in this problem, saying I'm going to multiply those two together because it's going to be a lot nicer to work with. So my final answer is x to the fourth plus 2x squared plus 1. That's what happens if I multiply, square that, and multiply them together. You could have done it where you got where you just multiplied them out and kept going, but this was just a quicker way to do this problem.